So good morning and welcome. Good morning and welcome. So today we are dealing with the question of question number 4 in our handouts. Question number 4 in the handouts. And the question reads that the management of Ambo Limited are faced with a decision whether to build a new plant or expand the existing plant or subcontract some of the operations of the company in order to meet the increasing demand of the company's products. To build a new plant will cost shillings 20 million. Expanding the current plant will cost shillings 10 million. Subcontracting some of the operations of the company will cost shillings 7 million. The future demand of the company's products is expected to be high, moderate, or low, with probabilities of 0.2, 0.5, and 0.3 respectively. The projected sales revenue under the various options is shown below. So we are given that. Before making the decision, Ambo Limited could contract a market consulting firm to conduct market survey on the future prospects of the company's products. The market survey would cost the company shillings 2 million. The outcome of the survey could either be acceptable or unacceptable, with the probabilities of 0.4 and 0.6 respectively. The outcome of the survey is acceptable. The probabilities of high, moderate, and low demand would be 0.7, 0.2, and 0.1 respectively. If the outcome is acceptable, the probabilities of high, moderate, and low would be 0.1, 0.3, and 0.6 respectively. If the outcome of the survey is unacceptable, then Ambo Limited will not build a new plant. Now you are required to do a decision tree on that. Now in this case, we need to come up with a sketch. We need to come up with a sketch, and in this sketch, we know that this company has two options. The first option is that they can consult or not consult. They can consult or not consult. Now, if they consult, there are two possibilities. The report should be acceptable or unacceptable. And if the report is acceptable, they will either build, or expand or subcontract. But if it's unacceptable, they will only expand or subcontract. Now, if they do not consult, again, there are three possibilities. They will build, they will expand, or they will subcontract. Now, each of these is going to attract three states of demand. So there will be three of each. There will be three states of demand here. Three states of demand. So if you count 1, 2, 3, 4, 5, 6, 7, 8, that is 8. 8 times 3, that gives us 24. 8 times 3 gives us 24. So what you're supposed to do now is to draw a nice diagram. At the end of your book. So you come to where your book ends here, and when you get there, when you get to where your book ends, where the book ends, You draw 24 tails. You draw 24 tails. You draw 24 tails. It's a minute. Good. So we are saying we are going to draw 24 tails. So here you write the word payoff. You write the word payoff. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So there are 24 tails. So if there are 24, so this is 1. Got it, number 1 here. 3 of them. This is number 2. This is number 3. This is number 4. This is number 5. Number 6. This is number 7. And this is number 8. That's number 8. Then I have 3 options here. So number 9 and 10, you can see we have different designs. So you're supposed to observe the designs. You're supposed to observe the designs as they are coming out. Three. So this is now what we call the decision tree. Is what we call decision tree. From our notes, you can be able to see the meanings of all these items. From the notes, you can see the meanings. So be fast in drawing. So this becomes number 12 and this becomes number 13. So here we are saying we can do a survey. We can do a survey. And according to this question, the consultant is going to cost us 2 million. So that cost is put here. You put it in brackets that way. Then here we say no survey. So with no survey, there is no cost there. When you do the survey, the report that will come out will either be acceptable, or it will be unacceptable. It will be acceptable or unacceptable. And the probability that it is acceptable is 0.4, and acceptable is 0.6. Now, whatever that comes in, you will decide to build or expand or subcontract. Build, expand, or subcontract. And here, if it's unacceptable, you just expand or you subcontract. You expand or you subcontract. On this side, you again decide to build, to expand, or to subcontract. We are told that the cost up there, the cost of building is 20 million. So it's put here, brackets that way. Expanding is 10 million, you put there. Subcontracting is 7 million, you put it there. So the same case here, this is 10 there, and this is 7. Then here we have 20, here we have 10, and here we have 7. Here we have 7. Then when it comes to the demand, here we will use the initials because the lines are congested. So it is high, moderate, low, 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 high, moderate, low. And it's important down there you put a key so that we are able to know that 8 represents high demand. High demand. We are also able to know that M represents moderate demand. Moderate demand. And we are also able to know that L represents low demand. L represents low demand. Now, the probabilities that we are given there, the 0.2, 5, and 3, they apply before there is a survey. So here, the probability of high is going to be recorded here, 0.2, 0.5, and 0.3. 0.2, 0.5, and 0.3. 0.2, 0.5, and 0.3. Those are the probabilities before you do the sum. Then we are told if the outcome of the survey is acceptable, if the outcome is acceptable, the probabilities are 0.7, 0.2, and 0.1. So 0.7, 0.2, and 0.1. 0.7, 0.2, and 0.1. But if the report is unacceptable, there is a typing error there. It's supposed to say if the report is unacceptable, the probabilities are 0.1, 0.3, and 0.6. 0.1, 0.3, and 0.6. Those are the probabilities. Now, from there, we are supposed to put the payoffs. If you have built and it is high, we have 70, followed by 40, followed by 15. If you have expanded, we have 40, 30, 25. If you are subcontracted, we have 30, 20, and 25. If you have expanded, this is 40, this is 30, and this is 25. If you are subcontracted, this is 30, this is 20, this is 25. The same case here, 70, 40, and 15. 40, 30, and 25. 30, 20, and 25. So those are the values that we have there. Finish up to draw. So we should be through with the drawing now. So after you have drawn, the next thing that we need to do now is to compute the EMVs. So we come here and talk of computation of expected monetary value at node. So we start with node 1. Now what we do, you follow this node 1 here, where it is going. You take the probabilities that are there, you multiply with the values that are there. So if we do that, node 1 is going to give us 0.7 times 70 plus 0.2 times 40 plus 0.1 times 15. And then you subtract the cost that is coming in. There is this cost of 20 million, so you minus 20. And if you do that, you'll be able to get 0.7 times 70 plus 0.2 times 40 plus 0.1 times 15 minus 20, that is 38.5. We come and do the same thing with number 2. It will be 0.7 times 40 plus 0.2 times 30 plus 0.1 times 25 minus 10. So this will be 0.7 times 40 plus 0.2 times 30 plus 0.1 times 25. You minus 10 and you get 26.5. We go to node number 3, which will be 0.7 times 30 plus 0.2 times 20 plus 0.1 times 25 minus 7. So 0.7 times 30 plus 0.2 times 20 plus 0.1 times 25 minus 7, it is 20.5. 20.5. Yeah. Number 4, you do the same. You say 0.1 times 30. No, it is times 40. That's 40, which is there. Times 40. Then 0.3 times 30. That's 0.6 times 25 minus 10. So 0.1 times 40 plus 0.3 times 30 plus 0.6 times 25 minus 10 is 18. Number 5 is 0.1 times 30 plus 0.3 times 20 plus 0.6 times 25 minus 7. So 0.1 times 30 plus 0.3 times 20 plus 0.6 times 25 minus 7 is 17. When we go to number 6, it is 0.2 times 70 plus 0.5 times 40 plus 0.3 times 15, that's number 6, minus 20, so it's 0.2 times 70 plus 0.5 times 40 plus 0.3 times 15 minus 20, that is 18.5. We go to number 7 where we say 0.2 times 40 plus 0.5 times 30 plus 0.3 times 25 minus 10. That's 0.2 times 40 plus 0.5 times 30 plus 0.3 times 25 minus 10 is 20.5. Number 8 is 0.2 times 30 plus 0.5 times 20 plus 0.3 times 25 minus 7. So 0.2 times 30 plus 0.5 times 20 plus 0.3 times 25 minus 7 is 16.5. So when the lines that are going out of the node here are complete, as you can see, we multiply. We multiply, and if there is a cost that is coming in, we subtract. Now let's go to number 9. When you come to number 9, and the lines that are going out, they are incomplete, what we do, we select the highest, or the highest if there are 2. So in this case, it is the highest EMV at where those lines are going, 1, 2, 3. And when we come here, 1, 2, 3, the highest is this one. So we are going to take 38.5. 38.5. We do the same with number 10. It is the higher EMV at 4, 5. So 4 and 5, this and this, the higher is this one, 18. And we need to show where we are getting those ones. Like now, this 38, we have gotten it from number 1. So we mark that way. That is to mean that is the one that we have selected. Then this of 18, we have gotten it from number 4. So you come and mark this way. It is to show that that is what you have selected. That is what you have selected. We go to number 11. Now, when you're in number 11, the line that is going out, or the lines that are going out, you can see they are complete. So it is a case of multiplication. So we are going to take 0.4 times what we got where that line is going, number 9. Number 9, we got 38.5. 38.5 plus 0.6 times number 10. Number 10, we got 18. And because you can see the line coming in has a cost 2, we subtract. So we say minus 2. So if you take your calc, it will assist you to say 0.4 times 38.5 plus 0.6 times 18 minus 2 is equal to 24.2. Is equal to 24.2. Let's go to number 12. When we come here to number 12, you can see the lines are incomplete. So it's a case of selection. So I will say it is the highest EMV at 6, 7, and 8. So 6, 7, 8. So 6, 7, 8. So the highest is this one, 20.5. And that one has been taken from number 7 here. From number 7. Then I go to number 13. Number 13, you can see the lines going out are incomplete. So it's a case of selection. So it is the higher EMV. It's the higher EMV at number 11 and 12. So 11 and 12, the higher is this one, 24.2. Now here, we have taken it from number 11 here. So we mark it that way. So that is how you compute the EMVs. And after you do that, you now give the advice. You now give the advice. So the advice starts from here. Is do a survey, and if report is acceptable, this one we were told to build a new branch. Build a new branch, but if unacceptable, if the report comes out unacceptable, you expand current branch. Expand current branch. So that is how the decision is made. You do the survey. If it comes out acceptable, you build a new one. Or if it comes out not acceptable, you expand. And if for whatever reasons this customer decides they will not do the survey, then it is better they just expand. The last thing that you can be asked to work on is value of information. If they were to ask you a value of information, what we do in the value of information, you simply come here at the end, and you take the two nodes, you compare the difference of their EMVs. You take the higher, number 11 you equal higher, 24.2. What one number 12, which is 20.5. So that gives you 3.7. So 3.7 is the value of information. 3.7 is the value of information. I would like you to read question 5. Read question 5, then we design. Question 5. Okay, so I believe you have read the question. So if you have read, we can design so the question says that this guy was offered either to sell his land or not, and he could consult. So here you can do survey or no survey. The survey will either produce a bad report or a good report. Whatever report that comes in, this guy will decide to sell his land or extract. Sell or extract. Even here, when he has done no survey, he will sell or extract. Now, if he decides to extract, or when he sells, he just get cash. When he sells, he just get cash, that is all. But if he extracts, there are three possibilities. There are three possibilities of the minerals. There are three possibilities. So with that, it means that we are going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our tree will have 12 tails. So our tree will have 12 tails. Our tree will have 12 tails. So once you have done that sketch, I told you, you now move to the end of your page, to where your page ends, and you draw the decision tree. You draw the decision tree. Now here at the end, you write the word payoff. You write the word payoff. You write the word payoff. Then you determine 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if there are 12, now here you will get cash. Be fast. So this is number 1. This is number 2. 3 of them. This is number 3. This is number 4. This is number 5. This is number 6. Number 6. So we are saying here, we will decide to sell or extract. So So this is number 7, this is number 8, this is number 9. This is number 10. So this is number 11. That is the end of the tree, the decision tree diagram. Decision tree. So this is the decision tree. Decision tree. So in this case, as you are saying here, you can do survey, or you can have an expert. This expert, we are told by the question, is charging. The geologist is charging 2.4 million, so this one is put there. 2.4 million. Then here, no survey. So when there is no survey, there is no question, meaning there is no cost there. Now, the survey will either give us a bad report or a good report. A bad report. So what you do, those values that you can see there are the good, you add them. That is 0.44 plus 0.05 plus 0.01 is 0.5. So that's the probability of bad, 0.5, and good is therefore 0.5, because these two must always add to 1. They must always add to 1. From there, this gentleman can decide to sell his rod or to extract. And if he decides to extract, the extraction costs will be 1.6 million, as we can see in information 1. So the 1.6 million is put there. Here, you can as well decide to sell or extract. This will be at a cost of 1.6 million. Then here we have a sell, and here we extract at a cost of 1.6 million again. If Mwagemi decides to sell, he will receive cash, and the probability of that is 1. Just receives cash, and the probability is 1. But if he decides to extract, he can get nothing, can get none, or he can get medium deposits, or he can get large deposits. Can get none or large deposits. So what now you do, the probabilities that are given when we are bad, it is 0.44 for none, and 0.05 and 0.01. Now, these probabilities, as you can see, they are not adding to 1. So we use the concept that we call Bayesian. Bayesian. And that concept simply requires you divide each of these by the total. So we divide here by 0.5, and that would be 0.02. Here I divide by 0.5, and that would be 0.01. No, 0.1. Here I divide by 0.5, and this will be 0.88. So if you add those ones, they will give you 1. It will give you 1. When you add these 3, they give you 1. Here, when he sells, he receives cash. That is 1.0. If he extracts, he will get nothing, or he will get medium, or he will get ranch, or he will get ranch. And the probabilities, we treat them the same way. 0.26, you divide by 0.5, and that is 0.52. The next one is 0.15, you divide by 0.5, that is 0.30. The next one is 0.09, you divide by 0.5, and that will give you 0.18. Now here, you will get cash with a probability of 1.0. Here, you will get none. Here, you will get medium. And here, you will get large. You will get large. So the probabilities of those ones are the percentages that are given up there. The percentages that are given up there. So for no deposit, it is 0.7. For medium, it is 0.2. And this other one is 0.1. 0.1. Then from there now, we record the payoff. According to information 2, we are told when he sells, he will make sales of 9.6 million. So this is 9.6. Obviously, when he gets no deposit, he will get 0. If it is medium, he will get 40. No, sorry. Medium is the one giving 9.6. But if he sells, he will get 4 million. Yeah, selling is 4 million. Selling is 4 million. Medium, you're gonna 9.6. Large, gonna 40. So if he sells 4, this is 0, this is 9.6, this is 40, this is 4, this is 0, this is 9.6, and this is 40. So, that is how the tree is grown. That's how the tree is grown. So let's now move and compute the EMVs. Let us move and compute the EMVs now. We move and compute the EMVs. So we have said here, you say computation of EMVs. Computation of EMV at node, let's start with node 1. So as we have said, you come to node 1 here, multiply that probability with the payoff that is on the edge. So this will be 1 times 4. And the answer, I come to write it here, 4. When I go to number 2, we do the same. It is 0.88 times 0 plus 0.1 times 96 plus 0.02 times 40. Then you minus the cost that is coming in there. You minus the cost that is coming in there. That is what we have said. So if you take your calc, it will be 0.1 times 9.6 plus 0.0 times 40 minus 1.6. I'm getting 0.16. 0.16. Then you go to number 3, which is 1 times 4. And the answer is 4. Number 4 is 0.52 times 0 plus 0.3 times 9.6 plus 0.18 times 40 minus there is a cost of 1.6. It's a cost of 1.6. So 0.3 times 9.6 plus 0.18 times 40 minus 1.6 is 8.48. 8.48. When I come to number 5, it is 1 times 4. So this is 4. So the answer is 4. When I go to number 6, it is 0.7 times 0 plus 0.2 times 9.6 plus 0.1 times 40. Then I minus 1.6. Then I minus 1.6. So that will be 0.2 times 9.6 plus 0.1 times 14 minus 1.6. I'm getting 4.32. 4.32. Then we go to number 7. Number 7, these values, you can see the lines are incomplete. So it's a case of selecting. So we will say it is the higher EMV at 1 and 2. So 1 and 2, the higher is this one, 4. So I'll take 4 and I will come here and show that I preferred to sell that way. When I go to number 8, it is the same case that I need to select. So the higher EMV at 3 and 4. So 3 and 4, the higher is 8.48. And that one has come from number 4. This one, to extract. Is to extract. When I come to number 9, I will go again for the higher. For the higher EMV at number 5 and 6. 5 and 6. So I will go for this one. 4.32. And that one has been taken from number 6 here. Number 6 there. Then when I go to number 10, it is a case of multiplication. So this will be 0.5 times what we got in number 7, which is 4, plus 0.5 times what we got in number 8, which is 8.48. And then we less the cost of the survey, 2.4. So if I say 0.4 times 4 plus 0.5 times 8.48 minus 2.4, I am getting 3.84. 3.84. Number 11. Number 11, I should have a selection of, so it is the higher EMV at 9, 10. So 9 and 10 is one here, 4.32. And that one has been taken from number 9. Taken from number 9. So we say that after you do that, you offer your advice. You offer your advice here. And the advice is no survey and extract. That is what we are going to advise this client of ours. That he should not do the survey. He should not engage the consultant. And he should just go ahead and extract. And then when they ask you a value of information, they ask you value of information. I've said you get the difference between these two. So the value of information at number 9, we had 4.32. And number 10, we had 3. So 4.32 minus 3.84. That is 0.48. 0.48. So that is how you go on solving those kind of problems. So on your own, you shall handle question number 6. So your assignments. You shall handle question number 6 in the handout. Question number 6 in our handout. Question number 6 in the handout. Then let me see whether in the past papers there is a question you can handle. You can handle December 2012. Question 3. December 2012, question 3A. And December 2013, question 3. December 2013. There's also another one of May 2014. Question 3. May 2014, question 3. Yeah, so you can try those ones. And that will be good. So we are going to call it a lesson at that point. Then we shall tomorrow discuss or proceed now with another area that is called linear programming. Thank you so much.